Hello friends, this video on chemical bonding part 13 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 12. The next I told was the resonance structure. So experimentally it is found that the O3 cannot be represented by Lewis structure because it shows resonance. If you try to draw the O3 molecule, I think we have done this in the Lewis structure. We got two of the structure, either this or this, where I told, right, so oxygen single bond was 148 picometer, double bond the size reduced, it becomes 121. So two possible structure were there, but experimentally it found that we had the oxygen O3 molecules looks like this with the resonance here, and the size is 128. So it is neither 148, neither 128, it is 148. So experimentally they have found that in case where multiple level structure is possible, they have something called resonance and it makes things more stable. Right? If you see, the length is less, it is more stable. And this concept of resonance was introduced because experimentally they found something else, and using Lewis they found something else. Because using Lewis, whatever they got, it was experimentally not true, so they introduced the concept of resonance. They means the chemist. So according to this theory, if my single Lewis structure is not able to explain my structure correctly, then I take the multiple multiple structure are possible, so I take the resonance structure, which is more stable and which is the structure of the particular molecule. And please note that resonance stabilizes the molecule because the resonance hybrid energy is less than any of the single structure. Also, if you see that this resonance averages the bond characteristic. For example, in this case O3, the resonance hybrid energy is lower. If you take any of the canonical form, even if you take average, the resonance actually energy is lower. Right? So resonance makes energy lower. And also please note the canonical form which we have explained, it doesn't exist in real. So in the last case, as I told, was oxygen has something like this, O3, right? So this is what I explained using Lewis structure. But I'm saying that these doesn't exist. The only thing that exists is this guy, the resonance. These forms, they don't exist. The one in the circle, they don't exist at all. They don't have real existence, right? And it is not that they exist in this form for 1 second, this form for the second. It doesn't happen. So a lot of students have this doubt. They say that for 1 second it is in this form, for 1 second it is this form. It keeps swapping. That concept is wrong. It is not like this, that it exists in this form or this form. It keeps switching. It is not like that. It is always in the resonance structure. Always. This is the real structure. Real experimental structure. Right? So these doesn't exist. It doesn't keep on swapping the structure, right? And there is no equilibrium also. So some students are confused, saying that there is equilibrium and the shape moves from shape 1 to 2. Nothing like that exists. These shape 1, shape 2, they don't exist in real. They don't exist. Don't get confused. They don't exist in real. The only shape that exists is the resonance structure, and they are pretty stable, right? They are pretty stable. So don't get confused with these structure. The only structure exists is the resonance structure in the real world, and that is stable. And that their energy is even lower than the average energy which you take from these. That's why we say that the resonance makes the structure stable. Right? And for these kind of structure, the resonance hybrid, they cannot be depicted by a single Lewis structure. These structures are all wrong. So the moment you come about resonance, you don't think about single Lewis structure. You should talk about only the resonance structure. We'll take some examples for the resonance to make it out pretty clear on that. So let's take the structure of Ca3 minus 2. Carbon has 4 valence electrons. So 4 plus oxygen has 6. 6 into 3 because 3 oxygen and 2 minus charge to be add 2. So this becomes 24. So we have 24 valence electron to start. So carbon is the central, will add like this, CO3, right? So now for this we have used 3 bonds, that means we have used 6 electrons. So we are left with 18 electrons now. Let's make this carbon happy, the central carbon happy. The central carbon has 6 electrons, add 2 more, this becomes 8. This is carbon, so we are left with 16. Central carbon is happy. Let's make this carbon happy. This carbon has 2 electrons, it needs 6 more. So with 6 more, this carbon is happy. Or this oxygen is happy. This oxygen also has 2 electrons, it takes 6 more. So we are left with 4 electrons. This oxygen has 2 electrons, it needs 6 electrons, but we are left only with 4 electrons. There is a deficiency of electron. This oxygen is sad. So this oxygen will say, okay, let me do a double bond with carbon. So let's propose a new structure for this, right? And let's try the whole thing once again. So we have 24 valence electron to start with. So now we have 4 bond. So 8 electron is needed in 4 bond. So we are left with 16 electrons. Let's see the central carbon atom. It's happy. It has 8 electron. Let's see this carbon atom. It needs. It has 2 electron. It needs 6. So let's add 6 here. So I'll put carbon 1. Sorry, oxygen 1. Let's name this 2 and let's name this 3. This oxygen has also. So we are left with 10 electrons now. This oxygen also has 2 electrons. It will need 6 electrons more. So let's add 6 electrons to oxygen 2. We are left with 4 electrons. This oxygen atom has 4 electrons. It needs 4 more. So give 4 to oxygen 3. And we have 0 electrons left. And all the oxygens are happy. All the carbon is happy. Everybody is happy. This is my structure. But let's talk about the charge now. Charge for this carbon will be how much? This oxygen will be how much? Oxygen 1 I'm talking about. 6 is the natural value it has. Minus 1, 2, 3, 4, 5, 6. Lone pair. Minus 1 bond. It is minus 1. So there is a minus 1 charge here. Talking about this oxygen 2. 6 minus 1, 2, 3, 4, 5, 6. Minus 1 bond. So minus 1 charge here also. Talk about oxygen 3. 6 is the valence electron it has in natural state. Minus 4 it has now. And minus 2 bond. So it has 0 charge. So if you see, that's how the minus 2 charge comes here. Minus 1 and minus 1. Correct? So the point here to note here is that instead of taking a double bond for oxygen 3, we could have taken double bond for oxygen 1 also, or double bond for oxygen 2 also, right? All these 3 structures is possible. Correct? All these 3 is possible. So in one case the double bond is here, double bond is here, double bond is here. All these 3 structures is possible. That's why we say that resonance exists here. And none of these structure will give you proper shape. The proper structure will be something like this. The resonance will be somewhere. And it will have minus 2 charge. Correct? This is my resonance structure. This is correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.